So how would housing recommendations work in our system? First, we need to ingest the ratings of all the houses that have already been done by our users when we showed them specific houses. So we have to go to our inventory of rentals and ingest the ratings for the houses. These ratings could come from explicit ratings. Maybe we showed the user the house in the past and they clicked 4 stars after seeing the house details. Or the ratings could come from implicit ratings. Maybe they spent a lot of time looking at the website corresponding to this property. Then we'll train a machine learning model to predict a user's rating of every house that we currently have in our listing database. We will then pick the top 5 rated houses that they haven't already seen. People who are not aware of recommendation engines somehow think of a car appearing on their Facebook feed because they happen to read an automobile review article. They say, oh, I was reading this review article and then just kept seeing cars in my Facebook feed. That's not the case. Reading the article caused the rating of all cars to go up, and the ratings of other items that are not cars to stay relatively the same. And this caused the highest ranking car to get into the top 5. So there was always a rating for the car. The car was always there, but its rating was simply lower before they read the article in question. So, how would we predict a user's rating of a house, particularly if they haven't seen it before? The model is based on 2 things. It's based on your other ratings. What have you rated other houses? And other people's rating of this particular house. A particularly simple model could be to look at all the users who rated this particular house and find the 3 users in their list who are most like you. Maybe they live in your country, maybe they have the same age, maybe they went to the same college. Find the 3 users in that list who are most like you. And then the prediction is the average of those 3 users' ratings. This is not a great model, of course. It's too easy to game. Think about what happens if 3 people gang up together and rate a house that nobody else cares about. So there are only 3 ratings for this house. So the 3 closest users are going to be these 3 people. So for sparse houses, it's really, really, really easy to game. But this idea of using user ratings of a particular house and users like you helps convey the basic premise of how recommendation models work. So where is the machine learning here? Where is the learning? The model would have to figure out how to find the users who are most like you. How many users to consider? 3 users, 5 users, 7 users, how many? And how to weight the different factors, such as the overall popularity of the items you have in common, and so on. This can be done by seeing what parameters help predict if you intentionally withheld ratings best. So we may have thousands of items and only 2 to 3 reviews per item. The chances are those reviewers have nothing in common with the user that we want the rating for. So, because this rating matrix is extremely sparse, we need to cluster items and users together. To put this in a more intuitive way, imagine that all of your friends drive SUVs, sport utility vehicles, and you read an article on Porsche. The car that appears on your feed might be a Porsche SUV, even if the article was on Porsche cars and all your friends drive Toyota SUVs. The machine learning model is imputing a rating for a Porsche SUV that is quite high, even though none of your friends rated it. So the machine learning model is essentially asking, who is this user like? And secondly, is this objectively a house that people tend to rate highly? The predicted rating is a combination of both these factors. All things considered, the rating of a house for a particular user will be the average of the ratings of users like this user, but it's calibrated by the quality of the item itself. Now that we understand the problem and the approach, we need to address the last question, the infrastructure question. How often and where will you compute the predicted ratings? And once you have them, once you've computed these ratings, where would you store them? What do you think? How often and where will you compute the predicted ratings? It's not as if rental recommendations have to be updated every time some user somewhere rates a house. We don't need to update the rental recommendations every time a new rating appears in our system. It's probably sufficient if we update the recommended houses for users once a day, maybe even once a week. In other words, this does not need to be streaming. It could be batch. On the other hand, we will probably have thousands of houses and millions of users. So it's probably best that we compute the rating that every user will give every house. We do that computation in a scalable way. We don't want to do it on a single machine. We want to do it in a fault-tolerant way that can scale to large data sets. So a typical solution for computation that has to happen over large data sets in a fault-tolerant way is to do it in a big data platform like Apache Hadoop. Finally, where will you store the computed ratings? Why would you want to store them? Well, we probably want to power a web application with these recommendations, and we don't want to compute recommendations when the user visits a web page. We want to pre-compute these recommendations. As we said, it's a batch job. So once a day, once a week, we pre-compute it. And then when the user logs on, we want to show that user the recommendations that we pre-computed specifically for them. So we need a transactional way to store the predictions. Why transactional? So that while the user is reading these predictions, we can update the predictions table as well. Assuming that there are 5 predictions for every user, and we have 1 million users, that's a table of just 5 million rows. It's small enough and compact enough that a typical solution for this would be to store the data in a relational database management system, an RDBMS like MySQL.